Hello, everyone, and welcome to another Tobii webinar. My name is Mariana, and I will be your host today, moderating the event. We could let for a couple more minutes and allow for more people to join. And while we do that, maybe I can introduce you a bit to the topic of today's webinar. We will focus on a topic which, in my opinion, is quite rarely addressed, and that is using eye tracking in a classroom setting in terms of or in the context of education research. When talking about eye tracking, we tend to make a basic distinction between screen-based eye trackers, which we mount on a computer screen, and we typically use those in a controlled lab environment. And then we have wearable eye trackers, which are worn like glasses. And so we typically reach out for the wearable eye trackers when we want more ecological validity and we want to allow our participants to behave in a more natural way or something that is closer to their natural behavior. In an educational context, however, there is a setup, a classroom setup that could fall somewhere in between, in a sense that we have students who work on their computers during a class, so where much of the tasks they are actually completed individually, and so their gaze or their eye movements could be tracked with a screen-based eye tracker. On the other hand, this is quite different from a controlled lab environment in a sense that they are surrounded by their peers, they might be surrounded by noise, and such a classroom environment also invites social interaction. And so it is a quite different environment from both a lab context, but also this in the field wearable eye tracking context. And so I was very interested in learning more about the benefits and challenges of setting up an eye tracking classroom and equipping a full classroom with eye trackers, which is why I have invited two renowned eye tracking classroom labs, so to say, from Germany today. So we will have speakers from Munich and from Regensburg, so both from Bayern or the south of Germany, and they're going to tell us about their experience with eye tracking. So I will present the agenda to you today. So we will aim to spend the next hour together. First, we will hear about the lab from Munich, and then the eye tracking classroom lab from Regensburg. As you will see, the first talk is given by Dr. Küchemann alone, but the second one is actually delivered by a full lab of Professor Mottok from Regensburg. And then finally, at the end, we're going to have a Q&A, a round table Q&A, where we will, in addition to all the speakers, also have one of my colleagues, Kirill, who will support us as well and be part of the discussion. So before we start, there are typically two questions we tend to get at the beginning of these online events. First of all, asking questions. I would love to receive a lot of questions from the audience, and I would like to encourage you to post your questions as they come up. Whenever you feel there is something you would like to get clarified, please just write it in the chat. However, we will not be answering them immediately. We will answer all the questions at the end during the roundtable Q&A. We've seen in the past that this is quite a nice setting for answering questions, because this allows all the speakers to actually express their opinion and add their perspective on every question that comes up. And this can then create a nice discussion environment, which is what I would like us to have today. Right, so please ask your questions and we will answer them all or address them all at the end. And then finally, an often asked question is, will there be a recording of the webinar? And of course there will be, so anyone who has registered for the webinar will also receive the recording. So there is no need for you to take notes unless you want to. You will be able to revisit the recording of the webinar and watch it again. All right. So without further ado, let's start with the first talk. So we're having Dr. Stefan Küchemann with us today. He's a group leader for artificial intelligence in physics education at Ludwig Maximilians University in Munich, so the famous LMU in Munich. You might have seen his face before if you have been following Tobii webinars in the past couple of years. In his group, Stefan has been using not only screen-based but also wearable eye tracking, and in the past he has been presenting their work in terms of wearable eye tracking, but today he's going to talk about something totally different, and that is the classroom setup that they have. So Stefan, please join me on stage. Welcome.
Thank you.
I will allow you to be the presenter now and will disappear for a while and allow you to talk.
All right, thank you very much, Mariana. So thank you to all the organizers for inviting me today and giving me the chance to present our work here today. Yeah, I hope you can see my screen now. Please complain if you don't. This work actually of Jochen Kuhn and myself started already when we were at Technical University Kaiserslautern, now changed actually recently his name to Rheinland-Pfälzische Technische Hochschule, University in Kaiserslautern. And there we worked together with DFKI, the German Research Center of Artificial Intelligence. And we wanted to create a more an environment which has a higher curricular validity, ecological validity, which closely resembles that of a classroom, so that teachers can actually come to the DFKI and where we have not only eye tracking but several sensors to understand that we understand how they're learning, how they solve problems. I will tell you a little bit about it and some preliminary results we have gathered here in Munich, where we also set up a similar lab with less sensors, but the eye tracking still came with us. But let me briefly tell you a little bit how this is actually going to look. So I'm going to give you a little bit of an introduction and why we actually chose to do a screen-based eye tracking in contrast to mobile eye tracking, and also present some relevant prior work, also in classroom settings where screen-based eye tracking has been used. I will show you how our classroom looks and what actually changed to a classical lab study, then some preliminary results and discuss this. Just to give you a brief idea of what has been done, just a brief review. This is not only related to physics education research where I'm from, but to in general educational research. We are also discussing this educational research quite a lot here at the special interest group at the European Science Education Research Association, the X7, which focuses on eye tracking. And when you look through the literature, you know that a majority of eye tracking studies was carried out in a laboratory. So they are under very controlled conditions. You examine 1 or 2 participants at a time when they are, for example, learning or solving problems in our case. And so this is under minimal disturbances. You have very light controlled environment, no social interaction, and so on. And you get some gains from it, of course. You have some roles that can play. These are the aims which have been mentioned previously in a review. So of course you can somehow learn a little bit about information extraction, problem solving strategies. You can also evaluate your material and see how effective that actually is, apart from only performance scores. And you can also prove learning theories. So apart from that, there's also, of course, when you go away from the cognitive level and perceptual level, you can also check some metacognitive aspects. The problem here, however, that it is always a question, how much does these results, what you find there, translate to a classroom setting under real conditions? So where you do not have these minimal disturbances, are they still valid? So how does it work in actual educational practices? So there is, in general, as you can see already with this, there's a great need of eye-tracking studies in the real settings. So the question is, how do we do that? And there have been, well, so first of all, some general aspects of field studies. So field studies, I mean studies in a real learning environment or a studying environment like a lecture hall or a classroom. They have, as I mentioned already, a high relevance to prove that the effects also exist. There are few studies where actually the social impacts, which is one additional aspect to consider, play a role on eye tracking. But I mean, that is a very common case. And so it's most likely affecting very strongly the case. So, and then, of course, the mobile eye tracking studies have a great advantage because they are very flexible, dynamic, and you can use them in all sorts of environments. But it can be that this analysis of mobile eye tracking takes a little bit more time. And for example, you also, when you have a single stimuli, which is the same for all of the students, then it's sometimes maybe even easier to use screen-based eye tracking. So there are some activities in a classroom where that can be performed on a PC, like when their students are learning, they're reading something or solving problems. Very similar to what we study actually in the lab. There are such activities do take place, as you all know, in classrooms. So so there is a need of eye tracking field studies in classrooms. And as I mentioned here, I mean, there are activities in which screen-based eye trackers can actually be used. Apart from this, there are also, just to mention that there are some studies with mobile eye tracking from the perspective of a teacher. So what has been found was in such studies, I want to go through it in detail in a moment, but first of all, I need to tell you a little bit on the reason why we actually do this study. It's not particularly related to why we do it in the classroom, but more related to the content itself. And in physics education, it's very important to receive a complete mental model to include several types of representations. Representations are depicted here. They show, for example, a graph or an electrical circuit, or a representation could be also here for a global map of the corona outbreak from 2020 and May 2020. When you have these representations included in a learning material, students need to deal with it, and that sometimes that can also be unsuccessful. So, but it's not only about the representation. They actually are supposed to learn with the representation some content, so they gain some conceptual understanding in physics. So, but to have that, and that is really successful, they need some representational competence. And that implies that they understand how a representation depicts information, that they can make connections between representations, and that they are able to actually select the appropriate representation for the content they want to learn. Now to the field studies in eye tracking. This is, for example, one setting that is reported in literature. And this is here from Bilikova. And there are a few reported group settings like that, where the classroom or computer room is, however you want to call it, they are mentioned here. You have a list of literature where you can dive into if you want to have have more details on these studies. And what is characteristic about this is that they often have a central control unit. I mean, the teacher may lose control of some participants if he cannot instruct them from the front to what to do on the screen. And if something is not working, it may be a little bit tedious and time consuming to go through each of the students to set it up, to do the calibration and so on. So a central control unit has been reported to be very helpful in this case. Then we have what I mentioned before already, social influences. We have between participant interactions, and that of course affects gaze recordings. The focus on the screen and the material. So there are disturbances apart from these interactions or additionally to it, just by noise, for example. So because of that, there are certain types of experiments that may not be possible. For example, when you do a retrospective think aloud, wherever it requires some verbal expression of the participants, it may be very disturbing for others. So there's also been reported that there may be some organization issues. I mean, as you can imagine, you have less control over individual participants and fewer instruction options. So you basically do a general one-fits-all instruction and hope that most of them can follow you. And then you attend each of the ones who cannot. But this can be, it may require tighter scheduling. Okay, so what did we do? That's our eye tracking laboratory. This is actually a picture from Kaiserslautern still at the German Research Center for Artificial Intelligence. Ours looks very similar. What you can see here is that each of these screens has here a screen-based eye tracker, and they are arranged in the way that neighboring participants cannot see the screen of the others. So this was one purpose of this arrangement. Of course, when they turned around, they would. The teacher would stand here in this position. And of course, everybody who knows a little bit about eye tracking knows that you need some kind of light control. And of course, this is, even though you cannot see it here right now, there are some curtains to avoid incoming sunlight. So we had 23 participants in our this preliminary pilot study, which I'm showing you today, and it was about quantum physics. I didn't give you any input on quantum physics because actually to understand the results and it's more about the methodology, I didn't want to bore you with the details here. There was only one teacher who moderates the entire session, and there were 14 workplaces, so we carried it out twice. Yes, and each workplace is equipped with a Tobii Pro Nano in our case. So this is the material they received. That's what we manipulated. We had an instructional material here, for example. You don't need to read it, it's in German. It's about the superposition of two light beams, for example, or also of two photons. And what we instruct here, we illustrate either with this block sphere representation or with this circle representation. And then we do a pre-post test. So we had 5 different instructions, and before and after each instruction, we do a little test, which is identical before and after. So overall, it looks like this. We had a pre-test, the first topic, then we had the 2 groups, the circle representation blue and the block sphere here in red, the post-test for the first instruction and the pre-test for the second one, and it follows until the end. So this is relatively simple analysis in the sense that we had here the areas of interest are not very fine-grained. Rather, we separated here the representation from the text in both cases. So, and we generally compare text and figure in both cases the eye tracking data. So some of the results here, first of the related to the score, we see in blue again here the circle representation, red the block sphere. You see that there's learning gain in both cases from pre to post over all the concepts we instructed. And we see that there is a tendency, not significant effect, to a higher learning gain for the circle representation. But we are, as I said, I mean, there's a small number of participants, and that's why here this is not significant. Okay, and then if you look at each of these concepts we had here, the details don't matter. Just keep in mind they are different concepts. You see that the relative gain is here written on the y-axis from pre to post, and we see blue the circle representation has everywhere a higher or a comparable learning gain from pre to post. So it's not this observation here is not restricted to a single concept. It's a general observation. If you look qualitatively here at one of these instructions, you can see that, for example, I mean, here there's a text and you have the representation here, and you see if you compare just the representation, which is important for us, the text is nearly identical, nearly because there are some representational features that required an additional instruction. For example, that this is blue and yellow, and that there is an arrow pointing here. But if you look at the representation only, then you see that there's a relatively high focus here in comparison to the text, and which is not visible here in this case. And quantitatively, if you look at the results, you see here on the left side the total fixation duration on the figure and on the text. And blue, again, circle representation, and on the right side, the block sphere. And you see that in both cases, there's a tendency to a higher total fixation duration on the figure and on the text for the block sphere. And if you look at the mean fixation duration, there's also here in the case for the figure, a tendency to a higher mean fixation duration for the block sphere, and very comparable on the text. So let me just discuss this a little bit, just for the methodology aspect. What you can see, maybe I can tell you a little bit about this eye tracking data in general. What this means for us, how mean fixation duration is often interpreted in literature, is that it somehow reflects the complexity of the information you're trying to extract from your learning material or during the problem-solving process. So how we interpret this is that the block sphere is a more complex representation. That was our initial motivation, which I didn't mention today, to design a new representation. This circle representation was newly designed, and we tested it here in comparison to a standard representation in quantum technology. And we see that, as we expected, that this is somehow appears to be more complex, and also needs a higher visual attention to probably extract information and understand the representation. So back to the discussion, to the general setting, we see that, okay, it may be helpful, a central control unit, but it wasn't critical. We didn't have that in our case. What we simply did is we orchestrated the students to follow the instructions. And of course, this was not carried out in school. These were students at the physics entry phase. But for those students, it is not a critical condition to have a central control unit. What is great about this group setting, apart from the ecological validity, which we mentioned earlier, is that they reduce quite amount of time for the execution of these studies and the amount of supervision you need for it. So there was one teacher in the room, and he was supervising all these studies at the same time. And and this is, of course, very relevant as well if you think of, for example, if you want to do this in school or with students over many sessions, and they can only, you have a limited number of eye trackers, of course, it may be a problem because students also learn over time, and if this prior knowledge, what they're gaining, is a relevant factor, then this is a great setting for it. So because you're basically done after very few sessions when you have all the number of students you need for your study. So, and then yeah, you have a reduced number of supervisors per participant, and in our case at least the data quality was very good. I didn't show you the details here, but they were very comparable, but it was also probably because we had university students and they could closely follow the instruction. And yeah, it allows, it's really the preferred setting for university students, and just because we have, it's more time efficient. We are faster. We have our studies which we want to do completed in a shorter time. Just one word about future studies. Sorry, I'm a little bit over time, but yeah, you can see here that we're doing this a little bit adaptive environment, and where we use a physics textbook, and where the content adapts to the gaze of the student. Here there's some additional material shown here on the right side, depending on where the student looks, and there we also use the central control unit for the teacher, so he can do a simultaneous calibration, start and stop, and he receives a dashboard of the information summarized over all students. So that's what we are working on right now. So thank you very much for your attention, and I'm very curious about your questions.
Thank you, Stefan. Yeah, so keep your questions coming for Stefan that we will answer later on. And now we will move to our next talk. And just to remind you of what that is, that will be the classroom solution from Regensburg. And here I would like to invite the whole team from Professor Mottok to join me on stage. Professor Jochen Mottok is a professor of computer science and a professor for safe and secure software systems at the University of Applied Sciences in Regensburg. And today we actually have his full team of PhD students that are also working in this classroom lab. So we have Florian, Lisa, and Timur today with us. So I would like to invite you to start your presentation.
We are in Regensburg, as I told. We have a sunny day, and Regensburg is a fascinating city in eastern Bavaria, and it's called the Italian city of Bavaria. We have a very nice old city with fine buildings and a nice culture. So now we are in Regensburg, and because we have a nice culture, also we have an eye tracking laboratory. And this eye tracking laboratory is part of the software engineering laboratory for safe and secure systems. So our context is not in the foreground psychology. Our background is software engineering, and I'm professor for software engineering, and there are different tasks. And these tasks have to be done in quality, and there are methods and processes which are established in software engineering. But there's a demand for analyzing behavior, for analyzing reading techniques, for analyzing quality, for finding errors in what? in requirements, it's text, in UML diagrams, it's a form of graphical representation of software and of the software itself. And what's our background? So we describe it a little bit, our description about the laboratory. And in this enumeration, you don't see a study design. We have done a lot of studies and we have done papers and presentations. We will not speak about studies today. We will speak how to establish an eye tracking laboratory, and we report our experiences of an eye tracking laboratory. This is our story. So if you have other expectations, please visit us next week in Mission Monastery in Bavaria. We have a conference. It's a software engineering conference with a special eye tracking session. Tobii gives also guidance in this conference. So brief description and history, venue and equipment, capability, research at the classroom, and also aspects of using a classroom in education of empirical studies with eye tracking. This is very interesting, and this is also interesting for engineers, for computer scientists, for physics, and also for mathematicians. Also a little bit atypical, because this eye tracking was firstly used and established in empirical studies by psychologists and pedagogic scientists. Our eye tracking laboratory activities started in 2015, so we are now 8 years in eye tracking active. We had a first eye tracker we used, and then we asked the federal government in Germany for money to establish an eye tracking laboratory, and we got €500,000 in 2018. We invested this money in Tobii spectrum eye trackers. So our history is 2015, first eye tracking study, 2016, first publication. Then we got our first own eye tracker. We had the FH Invest program with funding. We got the money. We established an eye tracking classroom. We show you the room. It could be a better room, because our recommendation is have a room with less daily light. We have a room which is upstairs in a building and which has a lot of windows, and therefore eye tracking research is not so easy because of the distribution of daily light. Yes, and then we did our first eye tracking courses, networking activities. We speak about this. So it's interesting. If you have an eye tracking laboratory, it's a good base to make field tests. But we have in eye tracking the great question of programs. How many programs we have? How many students would join an eye tracking study, and so on. Therefore, it's a good idea to make networking, to connect with other research groups in the same domain you research, to make replication studies, to enlarge the number of programs and to get a better statistics. It's also an interesting topic in education. Later we tell about it. That the topics which are essential is that students learn how to make an empirical study. And this is new for the engineers where we are working. They had other research models and they are educated. Empirical study, preparing research questions, forming hypotheses, and in the end, after the study, the large activities of statistics. This is also an essential topic in education of eye tracking. Yeah, this is a team and all are here. So Lisa, Flo, Timur, all are PhD students. Flo will take the role of a postdoc in the near future, and we continue our research of using eye tracking in the software engineering domain. And because I told you about the necessity of replication studies, it's necessary to connect to others. And we have a connection to colleagues in the United States, in Canada, in Great Britain, in Scotland. We have Finland, we have also Holland, and we have also in Bavaria another guy, it's Andreas Gegenfurtner, who did also a lot of work in eye tracking, and Teresa Bussion in Berlin. So this is also an activity which is necessary. But why? Replication study have a higher number for the statistics. And now I give the task for presentation to my PhD student, Florian Hauser.
Okay, thank you very much, Jürgen. I will continue from this point, and I would like to talk a bit more with you about the venue and equipment at the classroom. So first start with the equipment. So back when we got the FH Invest funding, we were able to buy 14 Tobii Pro Spectrum eye tracker. Each one of them is a 600 Hertz version, whereas also 1200 Hertz version, but we decided to go with the 600 Hertz version. We were also able to get some, back in these days, I think it was 2018, relatively powerful workstations. We're still keeping up very good, and each single Spectrum is equipped with one of these precision workstations. Afterwards, I think it was by the end of last year, we were able to get 9 Tobii Pro Fusion eye trackers, which we're currently using mostly for mobile and field studies. So in this case, once we were with 3 Tobii eye trackers with the Spectrums at Munich at a conference, and well, everyone who has ever had one of the Spectrums knows it's a bit hard to sometimes to transport it. So it's much easier if you take just the Spectrum in one of these pockets we have bought for them and just carry it to the participants. It's much easier and really fun to work with them. And we were also able to get some VR stuff for our laboratories. So we got 2 HTC Vives, which are also equipped with Tobii eye tracking tools, and we are using them sometimes for some VR stuff we are currently doing. So I know one of the colleagues who did a bit of gaming research was very interested in using them and did a lot with them. Yes, and regarding the Spectrums and our mobile equipment, we are also using some mobile workstations. So every single Spectrum has 1 mobile workstation you can use for field study. And here on the slide, you can see just how the eye tracking laboratory in our case is set up. As Jürgen already said, you can see these blue lines. Our requirement was, can we maybe have a room at the basement with just a suitable amount of windows, not that much windows, but all the blue lines you can see here are just windows. So we really have to block the sunlight out there that we can do our studies, but actually it works quite fine. It's just one of the things you always have to keep in mind in this room. The classroom itself has 2 rooms in our case. So on the left-hand side, you can see the classroom, and on the right-hand side, you can see the observation room. Typically, we are using the classroom, of course, for our experiments and for data collections. So this is where 3 Spectrum eye trackers are set up. Normally, at least 11 of them are set up there. We have 2 stored as mobile units. For example, if we are just doing something at the university, we can just transport them in regards we need a Spectrum, and one of them is set up at the observation room. So for this reason, we're using always 1 eye tracker. This is typical, for example, when we are testing a new firmware from Tobii. We are also using a single unit, for example, for experimental setups when we are trying to test something out, and we are always using 1 eye tracker just to test everything before we roll it out to the classroom on the left hand side. Sometimes we have also used this room as a meeting room. Also for the HTC Vives, we have set it up as a VR lab, so you can also use it because in the middle of a room it's quite empty, so you have a lot of space to move around when you're wearing a VR glass, so that's perfect for it. And in many cases we have also used it just to conduct smaller studies. So when we knew, for example, that we will not have so many participants, we also use just a single eye tracker installed in this room to do the data collections. Okay, let's go to the next slide. This is about the capabilities of a lab. So since we are having the classroom, we have the advantage that we can carry out studies faster and with larger sample sizes. So this has 2 reasons. So on the one hand side, all the eye trackers in the classroom are connected to a local area network, and they can be operated from 1 workstation, which is good. For example, if you're taking all the students from a certain lecture to the lab, then you just can place it there in the lab, and it's relatively easy to operate also for 1 person there. This makes life a lot easier. And the other thing, especially Lisa has done in the past for her master thesis, was that we did several experiments at the same time at the classroom. So we just used 3 or 4 eye trackers and we just switched 3 participants. So we just shared them and they moved around. When we have finished at the first eye tracker, we went to the next experiment. This is also one of the things which really helped us just to get a lot of participants in a short time. And it was actually quite funny. But of course, you have always to pay a bit attention that the study designs really fit exactly to the participants. So it wouldn't make any sense to do some software engineering stuff and then afterwards something which is more related to language learning or something like this. So you always have to keep a bit in mind that you really have to make sure that the studies really work with each other. The other possibility we got by the classroom was the live streaming of eye movements. So this really opens up new experimental designs. So for example, you can stream the eye movements from one eye tracker to another one, and the participant can oversee it, can comment on it, or can also show his eye movements. Participants can so work corporately on certain task they should solve. So this really opens up new designs we hadn't in mind before. And it's also very interesting for teaching. For example, like we call it shared gaze courses, we're currently trying to implement, which is something like, for example, you as a teacher can observe your students while serving some different tasks and can correct them. If you see, for example, that they do something completely different as they should do, for example, if they have another strategy. So it can really immediately give some feedback and helps them to adapt to the tasks. Or otherwise, you can also act as a live model in this case and just show them how you solve some certain task and stream your eye movements to them. So this is one of the things we are currently a bit trying to set it up, and we'll test it probably in the winter term. We have some ideas in mind and are interested how our students will react to this, but it's a very nice idea for us. And regarding the Tobii Fusions, we are very thankful for the enhanced mobility they gave to us. So as mentioned before, if you're carrying around 3 suitcases with the Tobii Spectrum, it's not the funniest experience. It's a decent eye tracker which really provides us with most advanced technology and helps us to carry out the studies, but setting it up at participants, it's always a bit of problematic if you have to move them around. With Fusions, it's very easy. And I think a lot of you who are working with experts probably have the same experience as we have. For example, it's in many cases much easier to bring the eye tracker to a participant instead of bringing the participant to the lab. So for example, I did a lot of code reviews with experts and novices, and to get the experts out of a company and bring them to a lab, it's so difficult. In this case, we just grab nowadays with Fusion, go to the company, set it up at one of the offices, block the sunlight, and start with the experiments. So this makes life also much easier. And of course, we are using the classroom for research. Jürgen has already mentioned the typical things we are doing. And here is just a very brief overview. We have much more publications out there, but most of our research is focused on software engineering and all the different artifacts which are used in software engineering. So we did some studies on requirement engineering, where our students should model and formulate requirements based on natural text. We also did some UML modeling tasks, where we should model UML diagrams or review them. Then, of course, the code reviews, which are a bit of my personal interest due to my PhD thesis, which is focused on visual expertise in code reviews. So, yes, but there are also some other topics we are doing. For example, we had one master student who analyzed how syntax highlighting influences the performance during a code review. Another one was interested in coding guidelines, how they must be formulated to be as efficient as possible for the participants. And we have also some other stuff like with colleagues Jürgen mentioned from Scotland, we have done a phishing study. So we just had some participants looking on emails and should just tell us, is it a phishing email or is it really a true email without any hazardous effect on you? So these are some other topics related to software engineering in our case, but also very interesting.
And I add, in future we have a study for modeling SysML2, a new modeling language, and there are different artifacts. So the comparison of presenting different artifacts we had also in the presentation before is also a very interesting topic. And also there's mass Markov models with differential equations and with graphical representation. We did also a study. So for us, it's interesting how can the way of a novice student expert assisted by eye tracking. Okay, Flo.
Okay, then we can continue with the next slide. And of course, name already implies it somehow. The classroom is of course also used for teaching. Right now we have 3 different areas which were relevant for teaching. So on the one hand side, we have the eye tracking lectures. We are currently offering 2 eye tracking lectures, where one is usability studies with eye tracking, which is more addressed to bachelor students who are getting first contact with eye tracking and are learning the basics of eye tracking. And the other one is the eye tracking in engineering science, which addresses master students or also more advanced researchers who are interested in using eye tracking and who want to get a bit more in touch with the technology. So this is more the advanced course for us. So I will talk a bit about eye tracking in engineering science later, but we have also 2 other elements we are using the classroom for teaching. There is also a supportive function we are using. For example, we have recorded eye movement modeling examples. You might heard of EMIs in many different areas. We have recorded them for software engineering and really for every single part. So we have some for requirements engineering, we have some for UML modeling, for code reviews. So we really completely get through our lecture for software engineering, and for every single topic we have created at least one single EMI. And right now we did an evaluation study and had a look how it is accepted by our students, and we got really very positive feedback, and they wanted us to produce more of them. This is also one of the topics we would like to include in our lecture in the next term. But as soon as we have seen, so the feedback was really very good, and it also appears for the students that they profit from them. We will also like to evaluate it more in depth and see, for example, do they synchronize their eye movements with the strategies we present them? So there is so much to do in this area, but it's very promising right now. And of course, as I mentioned earlier, also one of the didactical ideas we have are the shared gaze lectures, which are something we would really like to test and see how the students react and what kind of feedback we get, if it helps in certain cases. So for example, there are some areas in software engineering, I'm thinking about design pattern, where it would be so useful for us as teachers just to see how are we really doing the tasks, where exactly are happening the mistakes, so that you can help them earlier. So this is also one of the things we will really try out. And the third thing we are doing in case of teaching are student projects. So students at the OTH have a possibility to do some seminar papers, bachelor thesis or master thesis at the eye tracking classroom. In all cases, we are giving them, if they are not familiar with eye tracking, just some basic knowledge, and we are also supervising them while carrying out their studies. So we help them to set up an own study design. We help them to get participants. We also, if possible, supervise the data collection, at least in the beginning, until we are familiar, for example, with the calibration, what they have to pay attention on and so on. And also afterwards, we are helping them with the data analysis and have a look, for example, what kind of results turns out. It's also very inspiring for us to see the students doing some seminar work and so on, because you get new ideas, you get new inspirations. It's always fun to work with them and you get so many new ideas. It's really a very nice situation to have a lab offering so many possibilities to the students. Okay, and let's talk a bit about the eye tracking and engineering science course. So this is the one we are using, for example, for our master students. We are offering this course every single term. It addresses it's not limited to them, but it addresses most of the master students from the Master of Applied Science at Research at 9 Bavarian universities. So they are normally a bit more into empirical work and are normally always looking for new tools they can use, for example, in their own projects. And so they are also interested in many cases in eye tracking. So when they are taking part in this course, we are really doing the whole research process. So we normally come to the course and have a certain research question in mind. So we help them to set up an experimental design and then also help them to do some eye tracking study and to with some data which you can analyze afterwards. And the task we have to do is to write a short paper in which we completely describe a study and all the results. For us, we have decided to set up 3 different sessions during the term in this course. We always start with all the theoretical aspects of eye tracking, which is the first session, where you also have the chance to get some first hands-on experience to the lab, because we made the experience as soon as you bring them to the lab, the more interested they are and the more creative the study designs are. The second part is always something which normally takes part remote, which is more like an individual coaching. During this coaching, every student who is taking part in this course gets an individual coaching, so we really have a lot of time with them. And we help them to set up an experimental design and helps them to identify all the dependent and independent variables, all the relevant metrics. It really helps them so that they finish the second part with a completed experimental setup. And of course, then they have to come once again to Regensburg, set up the experiment into the data collection, which is part 3 for us. And just to show you what most of them are doing, we have here a very short selection of topics from our students. So we had one student right now at the lab who was observing eye movements and their connection to certain learning styles. We also had one, this was a very interesting study, who evaluated different traffic plans with eye tracking and looked up which one is the most usable for us. Another one was also a bit more in case of usability. She analyzed YouTube thumbnails and how we had to be designed that they really grab your attention so that you click on a video, and that we also see sometimes other usability aspects like the usability of online shops and so on. So in this case, we are not limited completely to software engineering, but we are also offering a lot of usability stuff in this course. And let's go to the next slide. Every time we have finished the course, we normally have a lot of happy students in the classroom who got their first experience with eye tracking, and we're happy because they got some data, have to do some analysis, and normally we always try to make a great time out of it. So that's probably all of our presentation. Here you can also have our references, and if you have some questions, so just feel free and ask us. Thank you very much for your attention.
Let me just remind you, we now go into the Q&A part of the webinar, where together with all the speakers, I invite Stefan to join us as well. We also have my colleague Kirill, who is supporting us. Kirill is a research scientist at Tobii. He has been at Tobii for quite a few years now. He has actually a background in medical physics and more than 15 years of experience in educating and consulting scientists, mostly in terms of different technical aspects, and at Tobii then in terms of supporting scientists with their eye tracking journey. So Kirill is also here with us to help answer some of the questions and give his perspective to them. We have quite a few questions, but maybe we could start with one of mine, and that is, I would like to get from you this perspective, since you have both labs have went through the process of the idea of wanting to equip a classroom with eye trackers, and then actually getting the funding and means to do it, and doing it, and reaping the first fruits out of that decision. So I think it would be very valuable for the audience to also hear your reflections now, with some time distance of how valuable has it been, what have been the different challenges that you've been through, and what advice could you give to others who are contemplating the same idea. Stefan, maybe you want to start?
Yeah, this is quite a complex question, quite a lot of aspects there to consider. I mean, as I mentioned, I mean, this is our preferred way to perform a study. Actually, if the conditions do not have to be so controlled, or if we do not require verbal data from the students, then that is absolutely great because it's like we get in a very short amount of time an idea of like how is our material and so on. So this, I mean, so we absolutely very happy about that we went this step ahead. Of course, then there are other aspects which are always come into play when you invite a whole school class for their personal data and eye tracking data in general. But I think this would come anyway. It's just yeah, depending on the type of students participants you have. Yeah, so overall, it's a great thing. As I said, I mean, you have the additional option of performing something in a more ecological validity. So I think overall this is great. Some of the difficulties there, or I mean, you need when you do that, it's helpful to think also of the equipment apart from the eye trackers you need for it. So keep in mind that you need very similar screens or laptops ideally, so that your results are comparable. Yeah, think of if you need a central control unit. As I mentioned, I mean, if I assume I don't know for sure that if you have younger participants, then I guess it's very helpful asset. But for students, for university students, it's not necessary. So yeah, I think that's some of the insights and advices I could give.
Mm-hmm. Would Regensburg agree? Is there something you would like to add?
I think we can probably pretty much agree, especially on the part with the all the additional equipment you need. For example, as Stefan mentioned, so it's really important to keep all the things pretty much identical. And it's also, when a classroom is in use, very hard sometimes to really keep it at the same standards. So for example, that you make sure that all the eye trackers have the same firmware, that all the Windows updates are at the same level, that all your software is at the same level. So this is one of the things you always have to keep in mind. So it makes life easier in case of data collections, but they also need a lot of maintenance, which you have to do in background.
So you have to find an administrator for the eye tracking classroom for all these topics. If you are research oriented, the administrator is very often a PhD student. So the administrator function lives 3 years, and then the PhD is done. Then you need the next one, and you have a know-how transfer necessary. So this is a traditional problem we have at university with the moving resource, human resource we have. But this should be kept in mind that there is a know-how transfer.
Yeah, very important.
A lot of software which manages the automatic update of each eye tracking working place. And this must be configured, administrated, and so on.
Are there any additional challenges you have experienced in addition to, you have both mentioned that it's important not to have too many windows, or if you do, to control the light, but also that the independent work units are at a certain distance so that students do not see each other's screens. Is there anything else that you have experienced as a potential challenge in terms of noise in such an environment that is not typical in a lab, or is something that you haven't foreseen? Yeah, Stefan?
So yeah, maybe I can comment on this, because this was actually, there's one aspect I have in mind that is not so so easy to foresee maybe, and that is the person who's guiding the class. So I mean, you have some affordances on this person, and you need some person, like you have a teacher, but the teacher usually not aware of all the procedure in the eye tracking software and how to guide the students going through it. So so you need two aspects, two characteristics of this person who is basically can deal with a larger crowd of people and can guide them very well. Also is somehow is very familiar with the eye tracking equipment, so it can help the people. Of course, you can divide it among many shoulders and include more people, but in general, this person who is performing the studies has different characteristics than the one who's doing it usually in a lab. So that's just the point. And not everybody of our group could do it. We figured that out. So
yeah, it requires some talents or skills. We have a question for Stefan, but I think it's also interesting for Regensburg, although you haven't mentioned it. Stefan, you mentioned other sensors that you have used before. Which other sensors did you use?
So we tried the skin conductance and heart rate variability to get an idea of how much effort, stress they're experiencing. At the same time, we also tried to infer cognitive load from it, which also wasn't so successful, but that was the intention there. And then we tried thermal cameras. Thermal cameras also had some some research groups suggested that you can infer the effort the student is putting from the temperature on the forehead in comparison to the nose temperature. And then eventually we also used EEGs together with eye tracking, but not in a classroom setting. Yeah, but this is more reliably letting you giving you some ideas of the effort and load the person has. So these were the three, just to summarize, these were the three sensors: skin conductance and heart rate variability, thermal camera, and EEG.
Yeah, but all then with the aim of capturing cognitive effort while learning. Yeah. Have you used anything else in Regensburg in addition to eye tracking?
Not up till now, but as mentioned, something like the galvanic skin reaction, this was something we were very interested in, or EEG, but the problem is we need some persons with a bit of, who can at least interpret the data. So we are doing a lot with eye tracking, but additional sensors are relatively new to us, so we haven't used them now. It's something we are always interested in the near future. Yeah. Especially for the same reasons, for example, like cognitive load, it is something which is very interesting, especially in the case of expertise research.
And let me see which questions to choose. We are over time a bit, but I would invite you to stay just a bit longer to answer a few more questions. The questions that we don't manage to answer, we will answer per email, so that the audience doesn't worry about that. There are some that I believe also we at Tobii can cover, which are around the format of eye tracking data and so on. Maybe one question, this is something you have already mentioned, how do you calibrate all the trackers in the classroom? So maybe just to mention this difference between having one control unit and not having this solution. Maybe Florian, you could comment on how do you do it.
So in the original version, I haven't written it, so I must also say I'm not the one who did this classroom solution. This was one of our former master students, and as Jürgen mentioned, well, personnel rotates at the universities, so they come in and leave. But he really did it with mouse macros. So he really did it like an example. So like remote control for your for the workstations. When he started the calibration process, we were able to observe it from the central unit, and if we saw that the calibration had some issues, we really had to go to a workstation and did the calibration one more time manually.
And in your case, Stefan, you are then doing it on every individual computer, the calibration.
So actually it works quite well. Yeah, we do it on each individual computer, but we are orchestrating it, that we are saying like, okay, now you're seeing, for example, now you have to enter your participant name and so on. And once you see, I mean, we're telling them what's going to come, and then they individually click to start the calibration and perform it by themselves. So this actually has worked quite well.
Okay, and there is a question that we have already mentioned. Do you have a tech person dedicated to maintain the lab and the equipment? We've mentioned that this is important to have someone with that role, be that a student or a lab manager, maybe even better.
This is very essential. This is very essential because we had an anarchistic guest scientist and he did his own software updates on the eye tracker. And then we have a mixed version of Tobii ProLab, which does not fit in the files. So we had a really problem. So it's necessary that one person has in mind that all configuration fits together.
Yeah.
Very essential.
Yeah.
And to have a rule set for an eye tracking laboratory, we did a two-pager, and there are a lot of rules how to behave in an eye tracking laboratory. And this helps to give guidance, to have explained rules, and rules give the humans also security and safety.
Yeah, definitely. There's one question for you from Regensburg. I believe you have mentioned this when talking about fusions. And the question is, what do you mean by you can bring the eye tracker to the student rather than the student to the eye tracker?
In most cases, it's related to the experts. So normally, if you have students from the OTH, we take them to the eye tracking classroom because it's easy to reach. But in the case of the experts, it's really, for example, in software engineering, if you're looking for an expert software architect and you ask a company, hey, can he take part in a study for 1 or 2 hours? They will definitely say no. So you have no chance to get them really to a lab. In this case, you always have to make sure that you have some equipment you can really bring to a company. So if you think about it, for example, it takes them 2 hours just to go to the lab and back. And if you just say, hey, we have an experiment that lasts 15 minutes, can we have some of your experts and can they take part in our study? It's just a short amount of time. We have made the experience that they are much more willing to join your studies.
We did our first mobile studies with Tobii Pro Spectrum, and this is an expedition. We have a lot of cases, and this is an expedition, like expedition around the world. And if you have the Tobii Pro Fusion, you have small cases, and you can transport it very lightly, and it's very easy to make studies on another place. It's very good.
In your projects involving the use of eye tracking for educational purposes, in addition to metrics such as gaze and fixation, have you also used other metrics such as pupil dilation, distance to the screen, and ocular vergence?
In this case, we had, for example, so one of our former PhD students and one of our master students, we also did an ME study and looked how the eye movements are synchronizing. For example, we used the Euclidean distance, we calculated, but they also used the pupil diameter to see, for example, well, there was a theory that this also provides some kind of information about cognitive load, but for some reasons it hasn't worked as good as we expected. So this is one of the things we'll probably also try in the near future, but in this study, something went wrong with the stimuli. We still have no idea what exactly happened, but the data was not so useful for us. I think it was because one of the stimuli was a bit darker and the other one was brighter, and so I think this just reacted with the pupils. So there some biological process happened. We still have no idea what exactly went wrong, but it.
There's a good paper. Please.
Yes, Jürgen. No.
There's a good paper from Sharafi 2020 about first order, second order, third order, fourth order data in eye tracking. So there's a classification of matrix, and this is a good hint to select the right matrix in a study. And if you are not doing this, you have the so-called fisherman trip. You collect data, and you have no plan in the beginning what you want to analyze. So make your thought about the data or matrix in the beginning of your study design. This is the recommendation.
Yeah, this is a very important point, to first plan it very well and know exactly what to expect and what you will get from your data so that you can interpret it later on.
And
yeah.
if you have well-formed hypothesis, you have a relation from the hypothesis to eye tracking matrix. And then you can make the selection which data you use for this later analysis. This is our recommendation. Other studies, we have also seen other studies that did the fisherman trip, and it's not easy to make hypotheses later, to make the hypothesis and the related eye tracking data in the beginning of the eye tracking research process, in the phase of forming research questions and hypotheses.
Yeah. Stefan, you wanted to add something?
Yes, I just wanted to add something. So we didn't actually purposely did not look in this pupil dilatation. There was a nice work from 2017. Sorry, 2013 already from DG, I think, and PNAS, where they show that it's a neuroscience manuscript, and they talk about that the pupil dilatation is actually not a process measure, but an expectancy measure. So, and apart from all the effects that it has, like from the brightness of the screen, the stimuli, I mean, how bright it is, and it would change just by that. It is also affected from what you expect of the stimuli and your position towards it. So this, of course, somehow limits the applicability or interpretation as a cognitive load measure, as some do it, but that's why we refrain from using it as that.
Yeah, pupillometry is quite a complex topic. Requires a lot of prior research and understanding and preparation of the stimuli, so that at the end you are in full control of the data that you are getting, so that you can actually interpret the results. Yeah. Any tips on improving the accuracy of the tracking? For example, you mentioned ensuring curtains are present to control luminance. We have found that the angle works a bit better when subjects have their head tilted slightly up.
Regarding accuracy, my PhD student Timur Eser currently makes a study with a master student. They make it both about accuracy of eye tracking. So Timur can say a lot of things.
One thing maybe which is worth mentioning is the frequency with which you do your study. It has shown that the lower the frequency, the lower the noise in the data gets. So your precision of your gaze data improves if the frequency with which you record is lower. Maybe that's a tip I can that I can give. And there are some guidelines, for example, in the calibration process. If your stimuli have a white background, then your calibration background should also be white. For example, that is another tip I can give you.
Yeah, that is a good tip. I believe, Stefan, we have had such conversations before about the color of the background when you're calibrating, that it should reflect or be similar to how your stimuli is going to look like later on. Yeah, that is a very good tip. We've just received 2 questions regarding the papers that you've just mentioned, and if you could give the full reference. So if you could write it in the chat now, that would be ideal. If not, we can send an email later on.
We will send you the correct scientific citation later, and you can distribute in an email.
Yes, we can do that. Good. We still have quite a few questions, but maybe we end with one since we are already over time. But am I going to be selfish and ask my question, or ask you one of these questions? There's one. I will be selfish. There's one topic that I'm very excited about, and you haven't really spoken that much about, and that is In case of Regensburg, there is this shared gaze lectures. And also I know that Stefan has been working on this gaze-based or enhanced textbook. And I find these two ideas or topics very exciting. So in both cases, there is this AI aspect of helping the teacher conduct the teaching process in a way that is more tailored to the individual student. So when an individual student is having difficulties, this is something that is then collected, this information is collected and then given to the teacher to act upon in this or that way, or it is the textbook that is automatically acting upon this piece of information. And I hoped we would have some more time to talk about this aspect of your work, but maybe just quickly about what does this mean for the future of teaching, and how do you see the future classrooms in comparison to how they are today? Your classrooms are very much high-tech and futuristic, but if we think about the high school or primary school classrooms and what your work could mean for these teaching setups in future. I don't know if that was clear enough.
Maybe I can answer to this at the first. So, I mean, of course, on the one hand, it depends on the technological development that it somehow become affordable for schools to, when they have it. Once they have it, they have a very rich source of additional information. The question is just how to use it. And with this Hypermind or this textbook, this intelligent textbook, we are trying to somehow put this into little packages and exact, I mean, if you think of formative assessment, that they somehow adapt the way they teach it or the content they're teaching based on data, and you provide them a dashboard, but not only the dashboard, but also the information really necessary to extract from it. Then they can, I think, make a much more informed decision on what should they focus on. I mean, if they really see like, okay, what is effective, what I'm doing and what not, and where can I really spend my last 15 minutes doing, what would benefit most of the students, I think that would be great if we could assist teachers in this way.
Yeah, other comments from Regensburg?
So we have, despite technical research projects, we have also educational projects, starting with the Quality Pact of Education. Now we have artificial intelligence in the university education as program. So we have the idea of adaptive learning management systems. In the philosophy of constructivism, we provide individual paths through the learning content, and integrating in this individual path eye movement assistance by eye movement modeling examples, or by collaborative work with gaze sharing, we see potential for future digital learning. But our philosophy is not only digital. Our philosophy is blended learning, so that we have also the reflection in a personal, direct dialogue. But you can integrate eye tracking in adaptive learn management systems, and these systems detect the learning path which is necessary for your optimal way of learning by artificial intelligence. And eye tracking data is also a source of information for us. We have a special experiment. Currently, we have a study to detect by eye tracking the learning style of a student. It's very interesting. We see a potential for the future in using eye tracking in the education area.
Nice, very interesting. Unfortunately, I think we need to wrap up. I would like to thank you so much for also staying half an hour longer than we planned. But I think both your presentations have been very valuable, as well as the discussion session. And it's usually like that there is not enough time for discussion, because we could always make it longer. There are still some questions that we haven't answered, but we will make sure to do that per email. I will share them with all the speakers, and we will then jointly work on them and answer per email to those whose questions are left unanswered. So one last time, thank you all very much. I hope you have enjoyed this experience as much as I have. I have learned a lot, and I hope it has been pleasant for you, at least.
Thank you very much. That's great.
Thank you.
Bye-bye.
Thank you. And see you soon,
Bye.
everyone.
Bye.